An automated milk bottling machine fills bottles uniformly to between 247 millimeters and 255 milliliters. The label on the bottle states it holds 250. So note there it was a uniform distribution. Determine the probability that a bottle selected randomly from the conveyor belt of this machine contains less than the labelled amount. Now I'm going to do a quick sketch of the distribution. So, fills uniformly between 247 and 255. That means that this gap is 8 units wide, which means the height here is 1/8. So if we want the probability of x being less than 250, so that's going to be 3 wide, it's just 3 out of 8. Calculate the mean and standard deviation of the amount of milk in the bottles, which is 4 marks. Well, it's a uniform distribution, so it's symmetric, so the middle of that interval is 251. The variance of x can be obtained by doing the expectation of x squared, take away the expectation of x squared, that is the integral from 247 to 255 of, so expectation of x squared is the integral of x squared f of x. Our f of x is just 1/8, so there's going to be 1/8 x squared dx, and then take away e of x squared, which is just that. And of course we can evaluate that on the calculator and take away the 251 squared, so that gives us 5.3 recurring, and then the standard deviation of x is just going to be the square root of 5.3 recurring, which is 2.309. A worker selects bottles from the conveyor belt one at a time. Determine the probability it takes the selection of 15 bottles before 5 bottles containing less than the labelled amount have been selected. So what we want is the 15th choice to be one which is less than that selected. And the probability of that is 3/8, as we established before. In the first 14 goes, we must have had 4 bottles that were underweight. So that is going to be 3/8 to the power 4. And if that's the case, then we must have had 10 bottles that were okay. And these could occur anywhere within the 1 to 14, so we need 14 choose 4. And then we calculate all of that and we get 0.0675.